Hello students, in the previous lecture video we have discussed the equation of circle in the diametric form. So in this lecture I am going to discuss the equation of circle in the parametric form. So let me write down equation of circle in parametric form. So I will just write down in brackets parametric form. So let us start with the simple circle first, which has center as origin, and later we will take up the case where the circle has a center different from origin. So let me choose the circle which is having its center as origin. So let me draw origin here, and the lines through x and through the origin, which are x and y, are mutually perpendicular. Right. So basically you can say they are the diameters of the circle now, because they pass through the center which is taken as the origin. Now if the radius of the circle is r, so all these distances which I have indicated are r here. So this point on the circle will correspond to r comma 0. This point on the circle will correspond to minus r comma 0. This point on the circle will correspond to 0 comma r, and this point corresponds to 0 comma minus r. Let's give them some naming. Suppose I name these points as a, b here, and these points as c and d. Now suppose if I want to find out any other point on this circle, let's say I have a random point chosen here P. I want to find out the coordinates of this point. First join O with the point P, and this is of course the radius r. Let's say the line OP makes an angle theta with OX, which is the positive direction of x-axis. And we'll now write down the coordinates of P using this distance r and this angle theta, and thereby we'll also derive what is the parametric equation of the circle. So if I draw a perpendicular from P here, say I call it as M. So this A is this point, so I'll write it here. So the perpendicular drawn is indicated by M. So M is the foot of perpendicular from P on this x-axis. Now you can see in triangle OMP, if you write down cos theta. So already you have learnt in trigonometry, when you consider a right angle triangle OMP, so cos theta is adjacent side OM divided by the hypotenuse OP. So we can therefore write this as OM is nothing but x coordinate of P. So if I choose P as x comma y, I can write OM as x. So this is our x and this is our y. So I can write this as x divided by r. Similarly, from the same triangle, if I write down sin theta, I can write down opposite side y divided by the hypotenuse r. So we can write y by r. So from these two you can observe that x is equal to r cos theta and y equal to r sin theta. So one of them gives you x equal to r cos theta and y equal to r sin theta. So now as theta varies, this point also will have varying coordinates, because x depends on r and theta, and r is fixed always for every point on the circle. Like even if I choose some other point q here, the distance is still r only. So this r is going to remain fixed, but for different positions of p, theta is going to change. Like for example, if p has moved to q, this angle theta will be some other angle called alpha. The angle will change. So since the angle is going to change here, what is the parameter here? Theta is the parameter, and due to which we also call it as the parametric form. So theta is the parameter. So basically parameter is with something which can have varying values. So theta is the parameter here, and you can observe for theta equal to 0 degrees basically. So if this angle theta is 0, P will coincide with this point which is R0. So you can say that P coincides with A, that is R0. So x will be R, y will be 0. It corresponds to this point A. Similarly, if theta is 90 degrees, the point P coincides with the point C, and x will be 0 and y will be equal to r. Similarly, if the point P is going to coincide with B, this angle is going to be 180. If P moves and coincides with B, this angle turn will be 180. So if theta is 180 degrees, we can say that x will be equal to minus r and y will be equal to 0. So like this you can see that as P moves on the circle, the angle theta is changing, and whenever theta is changing, the coordinates x and y are going to change according to this rule. So we can therefore say that this equation is the parametric equation of the circle. And you can obviously see here, when you eliminate theta by squaring and adding these two, you can see what is x square plus y square. When you square and add them, you will get x square plus y square equal to r square, because when you square and add RHS, cos square and sin square will add to give you 1, because we have a trigonometric identity, cos square theta plus sin square theta equal to 1. So this equation of the circle is called Cartesian form, and if you separately write down x and y in terms of a new variable called theta, which is varying, so this equation which you write for the circle can be called as parametric equation of the circle. And in case you write them in the form of coordinates, it's called parametric coordinates. So if I ask you what are the parametric coordinates of P, what are we supposed to write? We are supposed to write r cos theta comma r sin theta. So if you write it this way, they are called parametric coordinates, and if you separately write x and y values like this in the form of equation, this is called as parametric equation of the circle. So the parametric equation of circle having center at origin and radius as r can be written as x equal to r cos theta, y equal to r sin theta, where theta is a parameter. And for any point on the circle, the coordinates can be written as r cos theta comma r sin theta, which are called as the parametric coordinates. So this one I have done with reference to the simple circle which has center as origin, radius as r. So let me do it for a circle which has a different center like h comma k, and also I will do it for the general circle. So now let me choose the Cartesian equation of the circle as x minus h whole square plus y minus k whole square equal to r square. So corresponding to this equation of circle, I want to now write down the parametric equation as well as the parametric coordinates. So again I will draw the circle, but this time my center is not 0, 0, it is some h comma k. So let me draw the coordinate axis here. This is y axis, this line is the x axis, and we have origin here. Suppose if the circle has center as h comma k and radius as r, and I want to write down the parametric coordinates for this. So what we need to do here is, we will shift the origin from 0 comma 0 to this point. So as a result of which we can get the x axis parallel to this, and this is the new x axis, and y axis parallel to this, which is the new y axis. So let me draw the new x and y axis, and now choose a point P on this circle, for which we can write two types of coordinates. One with reference to the old system, this one, and one with reference to the new system. So let me assume that the coordinates of P are x comma y with reference to the new system, and small x comma y with reference to the old system. So what does this mean? When I drop a perpendicular from P to this x axis, say I call it as m, distance from any point to x axis is the y coordinate, and because this is new x axis, this is the new y coordinate y. And if I further extend the perpendicular so that it meets x axis, which is the old one, so here, say I call it as m dash. So this distance from P to m dash is going to be your small y. This whole thing is going to be small y. The same way you draw perpendiculars to both old axis and new axis in the case of y also. So let this be Pn and this is n dash. So the distance Pn is the distance from y axis, it should be x coordinate, and because it is new y axis, it should be new x coordinate. So this is capital X, and this distance from small y is small x, because distance from y axis is x coordinate. Now once I have denoted these distances, let me name this center as C, join it with the point P, this is the radius r, and let us suppose CP makes an angle theta with capital X. And if it makes theta with x, suppose if I extend this line backward to cut this x axis, old x axis, this angle is also going to be theta, because these two lines are parallel and they are cut by a transversal, the corresponding angles must be same, so both are theta here. Now consider triangle CMP. So if you consider triangle CMP, which is right angle triangle, of course, the value of cos theta here will be adjacent by hypotenuse, which is this CM divided by CP, and CM is nothing but capital X, same as Pn, because this distance is Pn, CM is also same because these 4 points are forming a rectangle. So CM, Pn is a rectangle, so Pn should be same as CM. So therefore you write here X divided by CP is R. So from here you get capital X equal to R cos theta. From the same triangle, if I write down the value of sin theta, so we can write here opposite side, which is nothing but capital Y, divided by the hypotenuse, which is R. So therefore capital Y is R sin theta. Now let us convert these two results in terms of small x and small y. So we already have learnt in the chapter translation rotation of axis. Whenever the origin is shifted from 0, 0 to a new point called hk, this hk is called as a new origin. And we can always write a relation connecting the old coordinates, new coordinates, and the new origin. So what was that result we wrote earlier? Small x is capital X plus h, and small y is capital Y plus k. So this is the result which will connect the old and new coordinates whenever the origin is shifted to a new point. So using this, I will change both the equations. So for capital X, what can I write? From this result, capital X is small x minus h. From here, capital Y is small y minus k. So you can modify these two and now write down the new equation with reference to small x and y. So let me write that. So we have capital X equal to r cos theta written here, and from here you know the value of capital X is small x minus h. So we write here small x minus h equal to r cos theta, or x equal to h plus r cos theta. And from the other result, capital Y equal to r sin theta. Suppose if I change capital Y using this as small y minus k, we write y minus k equal to r sin theta, or y equal to k plus r sin theta. So we can therefore say this is small x and this is small y for any point on the circle chosen. That is, if a circle is having center as hk and radius r, any point on that circle is going to have this as the x coordinate and this as the y coordinate, where theta is a parameter. So these two equations represent the parametric equation, and if you write them in the form of coordinates like h plus r cos theta, comma k plus r sin theta, if you write them in the form of coordinates, these are called as the parametric coordinates for any point on the circle. So which circle I am talking about? I am talking about the circle whose center is hk and radius r, and such a circle can be written as x minus h whole square plus y minus k whole square equal to r square in the Cartesian form. So this was the Cartesian form of circle for which these two represent the parametric equations, and this will represent parametric coordinates of any point on the circle. So we have seen how to write down the parametric equation of circle having center as origin, radius as r. After that we have also seen how to write down the parametric equation of circle if the center is hk and radius is r. So let's directly write down the same result with the general equation of the circle. So we'll summarize everything and also write down for the general circle. So let me just write them in a tabular form. So in the first column I am going to write down the equation of circle. So you can better say Cartesian equation here. EQN is a short form I am writing for the equation. In the second column I am going to write the corresponding parametric equation of the circle. So I will write here parametric equation EQN in short form. In the third column I am going to write down the parametric coordinates for any point on the circle. So here I will be writing parametric coordinates. Right, so coming to the Cartesian equation, the first Cartesian equation I am going to write down is x square plus y square equal to r square, which is a circle with center, origin, radius r. The second circle is x minus h whole square plus y minus k whole square equal to r square. This is the circle which has center as hk, radius as r. And the third circle which I am going to write here is the general circle, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. This is called as the general equation of the circle. So for the first one, the parametric equation is x equal to r cos theta and y equal to r sin theta. So theta is a parameter. In the second one, the parametric equation is x equal to just the same thing as the previous one, but we'll add hk in the RHS. So this will be h plus r cos theta and k plus r sin theta. And the same way if you are going to write for this circle, it will be x equal to and y equal to. The center for this circle is minus g minus f. So the same result as this, but center hk is replaced with minus g minus f. So we write here minus g plus r cos theta minus f plus r sin theta. But since the radius r is not mentioned here, you have to write down in terms of the given quantities g, f and c. And in general form already we have learned for this type of circle what is the radius. So you can mention here where r is root of g square plus f square minus c. So for all the three circles I have written the parametric equations, and now I will write down the corresponding points, parametric coordinates for any point on such circles. So for this circle the parametric coordinates for any point are r cos theta, r sin theta. And for this circle the parametric coordinates will be h plus r cos theta, k plus r sin theta. And for this form the parametric coordinates are minus g plus r cos theta minus f plus r sin theta. So this is about the parametric equation of circle in different forms. So far in all the lectures that we have done so far, what did we cover? First we defined the equation of circle in standard form. Then we have defined the equation of circle in the general form. After that we have also discussed angle in a semicircle is a right angle. Then we have discussed diametric form of circle. Finally we have discussed parametric equation of the circle. So these are all the equations in the standard form, but in addition to this we will also discuss some special cases wherein we discuss the equation of circle again and those situations you will actually encounter in the problems. You may not by heart them as a standard result like this, but whenever you solve problems you come across such situations. So I will also discuss such situations as the general cases. So let's wait for the next video to do all that. So for the time being I will end the session. I hope you have enjoyed the video. So thanks for watching.